Hello friends, here I am Deepak Gopal Gangadhar, student of MIT OE, Civil Department student, learning in TY class. Here now we are discuss about the bridges. Here is the definition of a bridge. A bridge is a structure built on the span physical obstacle without closing the way underneath, such as the body of water, valley, or road for the purpose of following passage over the obstacle. Bridge can be a road, a railway, pedestrian, pipeline, canal bridge. The obstacle can also vary from road to a railway, over a river or valley. And bridge is the key element in transportation system for the reasons. It is likely to control the capacity. It is the highest cost per kilometer. If the bridge falls, the system fails. The bridge can be divided into two major parts. Superstructure. Superstructure of bridge is the analogs, a single story building roof. Substructure is the analogs to that, the wall and the column and foundation supporting it. Such your all you seeing this picture, the deck is over here. This is the deck system. It includes in superstructure, and this is the substructures. These are the resting columns for decks, and this is the footing for bridge or transfer the whole bridge load to the ground surface over here. Now the superstructures. Superstructure consists the structural member carrying the communication load. Communication or load communication. Handrail, barrier, flooring, supporting for a structural system such as the deck slab, T-beam, L-girder, arches, cables above the level bearing constitute an substructure. As we know, or it is the supporting system for the superstructure. It consists of the following elements: pier, abutment. Abutment is in where the bridge starts and ends. Those structures called abutment. Wing wall. This is a supporting structure. Foundation for the pier and abutment. Other than the part of the bridge structure are approaches, bearing or river training works like apron, retment, or slopes of the abutment, etc. Components of typical bridge: handrail, parapet, pier, abutment, wing wall, and foundations. Here are some photos for that. This is the barrier as shown in the figure. This is for no any vehicle or a transporter vehicle is slide down over the road and fall in the river or any crossing structures where we crossing over there. This is a sidewalk for the pedestrians, deck for asphalt, expansion joint. It is the uh, necessary portion which is useful in for the temperature traces which are developed due to the heat, temperature, or the vibration loads. This is some picture the barrier and raising wing walls, such all this the bearing over here which get the load from the deck slab and transfer it to the pier cap. The soffit slab beam, pier column, all these are the RCC bridge components over there. Some components of bridge: approaches, abutment, wing wall. Approaches in the sense the bridge design affect to length the communicate route WR with respective alignment of level called approaches. Abutment end support superstructure retaining earth and their back. Wing wall constructed with the both sides of the abutment retaining the earthen bank and the protection from the water action. Pier, intermediate support of the superstructure. Foundation, abutment, pier and wing wall, rest of the foundation such as the load will transfer the load to the subsoil. Span, center to center distance between any two adjacent supports and the clear distance between the support, it's called as a clear span. Economical span, span for which the total cost of the bridge structure is minimum. Waterways, the sectional area through which the water flows may be artificial or natural. Linear waterway, the linear measurement of the area along the length of the bridge. Classification, one of the most, the major part of the uh, this bridge lesson, the classification of bridges. Bridge can be classified in different ways depending upon high flood level, position of the bridge floor, interspan relation, nature of the superstructure action, alignment of the superstructure with respective obstacle, material, span length, or type of connection. Bridge can be classified in different ways depending upon high flood level, according to road level relative to the HFL of the river below. The non-submergible bridge HFL is always below the superstructure. The submerged bridge HFL is always above the superstructure. Such types of the submergible bridges are small culverts or near the villages where the high flood level is not the high flood level is during only the when rain is high for the 1 or 3 hours maybe its runoff is 1 or 3 hours, not more than that. Near about it may be 1 day or 2 day, but not all or the rainy season over there. High level bridge or non-submergible bridge. It is the bridge which does not allow the high flow water to pass over them. All the food water is allowed to pass through a vent. In other words, it carries the roadways above the highest flood level of the channel. Submersible bridges. A submersible bridges is the superstructure that allows the flood water to pass over the bridge, submerging the communication route. Its formation level should be fixed as neither to cause interruption to traffic during the floods or more than the 3 days, such as mentioned days or time or nor more than 6 times in year. According to position, floor relative superstructure, deck bridges whose flooring are supported or suspended over the level of bearings. Through bridges. These are the bridges whose floorings are supported on a suspended at the bottom of the structure, as shown in figure over here. According to the interspan relation, simple bridge, they included the all type of beam, girder, truss, bridges supported at the both end only. It's suitable for span up to 8 meter only. Cantilever bridge that are fixed at one end and free at the other end are used for the span from 8 to 20 meters. Continuous bridge that continue over two or more spans. They are provided for the large spans where the unyielding foundations are supported. Look, such as over here, these are the cantilever span over here. This is the free end. This is all cantilever. This span is up to his and this. According to nature of superstructure action, arch bridges, portal frame bridge, truss bridge, balanced cantilever bridge, and suspension bridges. Truss bridge. So this is the photo of structural bridge. Balanced cantilever bridge. A cantilever bridge is built using the cantilever that projects horizontally into the bridge structure, space supported on only one end. For the small footbridge and cantilever may be simple beam. However, the large cantilever bridge designed to handle road or rail traffic and truss built from the structural steel or a box girder built from the prestressed concrete. Balanced cantilever bridge. One portion of the span is suspended for the rest over a hinge with the other portion of the span. This is a photo for balanced cantilever bridge. See, this is the cantilever portion over here, such, and this is another. The construction is over going on over here that reaches up to this another cantilever portion over here. Suspension bridge. Suspension bridge is the better suited for the crossing over very large boat ship navigation. This is for the where the creeks are or an major river is crossing to main lands over here. This is the Golden Gate Bridge. This is Golden Gate Bridge. The Golden Gate Bridge is suspension bridge spanning the Golden Gate, the opening of the San Francisco Bay into the Pacific Ocean. It has been declared one of the modern wonders of the world by the American Society of Civil Engineers. In for this bridge, this creek, what water flowing speed is too high over here. Wind blow is in summer or monsoon season. Wind blowing is 125 kilometers per hour. This is really a marvel of the civil engineering in the world. This is another type of the suspension or steel bridges. See the deck bridge, start of the bridge, tower for the suspender cables, main steel cables, which are those? These are the main steel cables. Over here. Light and strong suspension bridge can span distance from 200 feet, 2000 feet to 7000 feet, far longer than any other kind of bridge. They are ideal for the covering busy waterways, such I said earlier. Suspension bridges tends to be the most expensive to build. Main element, cable, decking, suspenders, supporting towers, anchorage cable. These are the main loading carrying member. Curvature of which change the load moves over the deck. Traffic loads are decking transferred to cable through suspenders. Stiffening of beam. The load transfer mechanism. Under suspension cables, those are such saying, which takes the load from the deck and transfer it to the main cable. And main cable carries the load and transfer to the this main column. Main columns to foundation. Sometimes their piles are also over here. Suspension cable pass over the smooth function pulley anchorage. The tension on the other side of the cable is equal to if the passes over the saddle pulley, horizontal component of the tension will be slight since the cable cannot have the moment relative to the saddle. Most of the weight or load bridge is transferred by the cables and the anchor systems. Structural analysis. This main forces suspension bridge, tension cables, advantage over the other bridge type. The suspension bridge can be made out of the simple materials such as wood and common wire rope. Longer main spans are achievable than with any other type of the bridge. Loss of material may be required. Less material is required for other bridges type. Even the span they are can achieve, leading to reduce the construction cost. Except the installation of the initial temporary cables, little or no access to from the below required during the construction. For the example following, the waterways to remain open while the bridge is built above. May be better to withstand the earthquake movements and the however the more rigid bridge is. The considerable stiffness and aerodynamics profile may be required to prevent the bridge deck vibrating under the high winds. This relative low deck stiffness bridge makes it more difficult to carry the heavy rail traffic over high concentrated live loads occur. Some access below may be required during the construction to lift the initial cables and lift deck unit. This access can often be avoided in cable stayed bridge construction. Classification of bridge. Bridge can be classified different ways depending on high flood level position, type condition. According to the relative HFL high level